Hello, everyone. If you have a chance, pull up your unit circle from your Google Drive folder. If you have it memorized, fantastic. That's going to serve you well in calculus sequence. Let's look at solving trig equations. Our first equation, we're going to look at solving sine x plus square root of 2 equals negative sine x. If you have the same trig function throughout, that's fantastic. Get that trig function all on one side of the equation. I'm going to add sine x to both sides. That's going to give us 2 sine x plus square root of 2 equals 0. Over here in the brackets, I've listed the general steps to solving on each equation. Some later on, I kind of wean you off of them. They're basically the same steps as algebra, but they just have trig functions instead of a single letter. Subtract square root of 2 from both sides, and then divide both sides by 2. Instead of isolating a single letter, you're isolating a trig function. Okay, so from the unit circle, we need to come up with the angles that have a y-coordinate of negative square root of 2 over 2. Remember, sine on the unit circle is the y-coordinate. 5 pi over 4, which is at 225 degrees, locate that. You'll see that your y-coordinate is negative square root of 2 over 2. And also over in quadrant 4, 315 degrees, or 7 pi over 4, that's the other angle. Both of those angles have a sine value of negative square root of 2 over 2. Back when we were graphing, recall that sine and cosine had periods of 2 pi. This goes back to coterminal angles as well. If you find an angle on the unit circle and you're dealing with sine or cosine, you will add, if you're asked to find all solutions, a 2n pi term, which just signifies complete circles from this angle. 7 pi over 4 plus any complete revolution, and again the period is 2 pi, n is an integer, and that's how you generate all solutions to a trig equation. Now, if you're asked specifically to stay between 0 and 2 pi, all you would give would be 5 pi over 4 and 7 pi over 4. In the next example, 3 tangent squared x minus 1 equals 0, let's isolate the trig function. So we're going to add 1 to both sides, divide by 3. To get it to tan x, we need to square root. From algebra, when you square root, you have positive, negative, square root, in this case 1/3. So tangent x equals positive or negative square root of 1/3. Well, what's the square root of 1? That's 1. Square root of 3, that's irrational. Rationalizing gives us this familiar looking fraction of square root of 3 over 3. Positive negative square root of 3 over 3 occurs at 4 angles on the unit circle. These two that have an uphill angle or slant are positively sloped. So these two angles, pi over 6 and 7 pi over 6, cover the positive square root of 3 over 3 value. Tangent of either one of those two angles is equal to square root of 3 over 3. These two angles are negatively sloped if you look at the tangent for each one. 5 pi over 6, 11 pi over 6. Now recall when we did tangent graphs, tangent has a period of only 1 pi. So when you record your answers, take the first angle you see here, pi over 6, And you only have to add 180 degrees or pi radians to get to the next angle that has that same tangent value. Pi over 6 plus n pi, not 2n pi. That's for sine and cosine, but for tangent, you add a multiple of pi. The next angle you get to is 5 pi over 6. And if you add pi radians or 180 degrees, that takes you to the other angle. So you take 5 pi over 6, add a multiple of pi, that will take you to an angle that has the same tangent value. This covers the negative square root of 3 over 3. These cover the positive square root of 3 over 3. Sine squared x equals 2 sine x. Be careful not to divide by a trig function. It's very tempting. Subtract 2 sine x on both sides. Or look at it as moving all your terms to one side. These two terms have sine x in common, so factor out a sine x. That's sine squared x minus 2 sine x, but it's in factored form. Note up here, we're only interested in angles between 0 and 2 pi. If you see this, then you don't have to worry about a 2n pi or a pi n angle generator. Set each factor equal to 0. Sine x equals 0. Sine x minus 2 equals 0. The angles within one revolution where the sine value or the y-coordinate is 0 happens at 0 and pi at those two angles. The other factor, when you add 2 to both sides, sine x is never equal to 2 because sine, remember from its amplitude, it has a range of -1 to +1. 2 is outside the domain, so this one has no solution. The next example, find all solutions of 2 sine squared x minus sine x minus 1 equals 0, only focusing on angles within one rotation or one loop around a unit circle. 2 sine squared x you can break up into 2 sine x times 1 sine x. The last term, 1, that breaks up into 1 times 1. Remember the O and the I from FOIL, the outer and the inner have to total up to your middle. -2 sine x plus 1 sine x is negative sine x. Set each factor equal to 0. Isolate your trig function, so -1, divide by 2. On your unit circle, find all angles that have a y-coordinate of -1/2. You should locate that at 210 degrees and 330 degrees. In radians, at 7 pi over 6 and 11 pi over 6. The other factor, when you add 1, the angle where the y-coordinate is +1 happens at pi over 2. And I've got those angles marked off here. 7 pi over 6 has a y-coordinate of -1/2. 11 pi over 6 also has a y-coordinate or a sine value of -1/2. Pi over 2, that's up here, it has a sine value or y-coordinate of +1. Solving 2 sine squared x plus 3 cosine x minus 3 equals 0. We do not have a uniform trig function. Using Pythagorean identities, you can rewrite sine squared x as 1 minus cosine squared x. That's an equal trade, and that's from Pythagorean identities. Now distribute the 2, that's 2 minus 2 cosine squared x, plus 3 cosine x minus 3 equals 0. Now we only have cosine, a uniform trig function throughout. Combine like terms, -2 cosine squared x plus 3 cosine x 2 minus 3 is negative 1. Since we're solving an equation, multiply all the way through by a negative, or in other words, change every sign. It makes it easier to factor if your lead term's positive. 2 cosine squared x you can write as 2 cosine x times 1 cosine x. The 1 at the end, you can write that as 1 times 1. Be very careful that the outer and inner combine to give you a negative 3 cosine x. Once you're sure your factoring is done, set each factor equal to 0 and then isolate your trig function. So for this first factor, we're going to add 1, divide by 2. The angles where the x-coordinate cosine is positive half is at pi over 3 and also at 5 pi over 3. Cosine has a period of 2 pi, so pi over 3 plus any full circle clockwise or counterclockwise will also be a solution. 5 pi over 3 plus any full circle, whether you go counterclockwise or clockwise, if it lands at this angle, it's a solution. The other factor was cosine x equals 1. The angle where the x-coordinate or cosine value is positive 1 is here. And that's at 0, if you go all the way around 2 pi. So any multiple, integer multiple of 2 pi will be a solution. Now we're going to look at a couple where the angle is not a single variable. These are called multiple angles. One example is 2 cosine 3 theta minus 1 equals 0. We're still going to start off isolating the trig component. So add 1, divide by 2. Cosine of 3 theta is equal to a half. Now, back to the unit circle, cosine is 1/2, positive 1/2 at pi over 3, or any full rotation from that. Cosine is also positive half at 5 pi over 3, plus any full rotation from that location. Solving for theta, divide by 3. This 3 on bottom divided by 3, that's going to be pi over 9. See if you can convince yourself of that. Dividing by 3 is the same as multiplying by 1/3. So that's pi over 9, divide both terms by 3. This generates all solutions to this equation, as well as the other one, dividing by 3. There's already a 3 down there, so if you multiply by 1/3, that gives you 5 pi over 9, and divide this generator by 3. Any integer n substituted in, whether it's 0, -1, +5, whatever, as long as n is an integer, correctly subbed in and added together will give you a solution to that equation. Same idea for the bottom example. Isolate your trig function. So I'm going to rewrite the equation, subtract 3, divide by 3. -3 divided by 3 is -1. X over 2, let's find out where that those angles are located, where tangent is equal to -1. Now remember, tangent is the slope. Tangent is -1 at these two angles, 3 pi over 4 and 7 pi over 4. So we're going to take x over 2 and set it equal to 3 pi over 4. We don't have to do 7 pi over 4 per se, because the period of tangent is pi. which means if you go counterclockwise pi or clockwise pi, you're going to take this angle and you're going to always land at that other angle as well. In other words, n pi covers that angle. That's one good thing about tangent, is you don't have to do each one separately plus a 2n pi. Tangent only has a period of pi, so if you can locate one pi radians around, you're going to get to the other. This one is x divided by 2. What's the opposite of dividing by 2? That's right, multiplying by 2. So we take x over 2, set it equal to 3 pi over 4, add a pi generator to cover all angles, and then times 2, 6 pi over 4 reduces to 3 pi over 2, and then this 2 multiplied here gives us 2n pi. So basically you're multiplying all three terms by 2, and that'll give you x. N is an integer, and whether you plug in a negative, positive, or zero whole number, sub it in, correctly add, you get an answer to the equation. Let me know if you guys have any questions. Send me an email, phone call, Zoom, whatever you need to do. Ask during class. And hope this video helps.